Hi guys, I am Mushakwa Ellen Tangeni with Maths XYZ, and in this lesson we'll be still continuing with financial mathematics, and I believe that since we have started with this chapter you guys are learning a lot from our channel. Alright, remember we did in our previous two lessons we were dealing with the effective and nominal interest rate, of which, just a quick reminder, the nominal interest rate is the interest rate that you are being quoted at the bank, and also the effective interest rate is the interest rate that you will receive after the compounding period has been added. Alright, here we will just go straight into a question and see how to answer missed example, especially those that will need to draw a timeline to be able to answer them in an easier way. Alright, the question that we have here, it says, on Linda's 8th birthday, her parents set up a fund for her. The rules were she will be allowed to withdraw 20,000 on her 18th birthday. That means that it will be 10 years later after the initiation of this account, and a further 25,000 on her 21st birthday. If the fund offers 10% per annum interest rate compounded quarterly for the first 4 years, and thereafter 8.5% per annum compounded monthly. That means that in this case, the interest rate will it was not a fixed interest rate for the entire lifespan of the account, but then it changed after after how long? 4 years, and then it was less, in fact, compared to the original interest rate of 10%. This time it is 8.5% per annum compounded monthly. The only advantage with this one is that it has been compounded monthly, and the first one it was compounded quarterly. The more you compound, the higher your investment becomes. So with the first one and the second one, it will be actually, it might be equal, but if they were both 10%, this one was going to be a much higher compared to the first one because it was quarterly. And then the question says, how much did Linda's parents initially invest? So we have no amount, we don't know the amount that they initially invest, which is what we are trying to find here. And the second question says, hence, I'm sure they say we're using the very same information. If Linda doesn't withdraw 25,000 on her 25th birthday, how much will she have on her 30th birthday? That means that it will be 9 years later from the 21st birthday. Alright, with this one, remember I told you guys it's better for you to first draw the timeline so that you will see clearly when did the interest rate change, and also if there were being any additional deposit, or if there's any withdrawal, then you will put it on your timeline, which makes it easy for you to answer the question. So I'll just do a rough one, of which this is 8, the T8, which is on their 8th year, and also here this is the 21st. Now we're just answering the first question. We haven't considered 30th birthday because this is the second question. This is the second half of the question. So on the 8th birthday, 20, we don't know the amount which was invested here, so I'll just put question marks in them. And what we know for those years from the 80th birthday, we know that it was 10% per annum interest rate compounded quarterly. So I'll just have 10%, and then it was compounded quarterly. Okay, just making a lot of space here. Alright, it was 10% at this time, and it was compounded quarter. So I'll just write Q for that for the first 4 years. So it was T8 up to T12. Remember that this account didn't start from year 0, but on the 8th year. So it will be up to T12 because we are now adding the first 4 years. And thereafter it was 8.5% per annum compounded monthly. So from the T12 to T21, here we find 8.5%. Alright, compounded monthly. This time is monthly. So let's also add the withdrawals on this account, where they say the rules where she will be allowed to withdraw 20,000 on her 18th birthday. So that means that is 10 years later from here. So on her 18th birthday, I'll write T18. So here she will draw 20,000 rands. 20,000 rands. So, and also on her, and a further 25,000 on her 21st birthday. So on her 21st birthday, this is the last amount that she will withdraw from this account, which is 25,000. Alright, that means that this is our final amount in this case, because this is the only amount that will be left in our account after 13 years of being invested. So our equation here, it will be A is equals to p into 1 plus I to the exponent of n, and then we'll add more when we continue with this. So in this case, we know that the final amount that she will withdraw is 25,000 here, and the initial amount that she will withdraw we don't know, so we'll just write p for this case. And we know that for the first 4 years it was 10% per annum, and it was compounded quarterly. So I will divide by 4 and also multiply by 4 in the exponents. And it says that furthermore it was 8,5. Then you remember with interest rate you only just multiply. So I will multiply with 1 plus 8.5% divide by 12. This time it's been compounded annually. I mean monthly, I mean to say. And then here it was only there for how many years? Sorry guys. It was there for 21 years minus 8, so it was 13 years. 13 years, and then that was only there for 4 years. So this account, the 8,5 only happened for 9 years, so it will be 9 multiplied by 12 then. Alright, and then to consider again the withdrawal, that means that we'll have to withdraw this 20,000, of which the interest rate, it was 8.5% for this one, divided by 12 as well. But this only happened for, it was on her 18th birthday, so from 21 years to 18, it only happened for 3 years. So here it will be 3 multiplied by 12. And from here we just calculate that and divide the A with whatever we would have found there, so that we will get the value of P. So the value of P here, it will be 25,000 divided by whatever that we will find from that amount, that sign. So that's 1 plus 10%, which is the interest rate for the first 4 years, divided by 4 to the exponent of 4 multiplied by 4, because it was compounded quarterly. So that we have to multiply by a quarter, which is 4. Then here we also have 8.5%, which happened for 9 years. So that will be 9 multiplied by 12, the reason being it was compounded monthly. Then we'll also have to subtract the 20,000 together with this interest of 3 years. So this 20,000 only happened for 3 years. 3 years before the account can come to an end. Alright, so that's 12% divided by 12 again. Reason being the 20,000 happened in the period of the remaining 9 years, where we are having 8.5% per annum compounded monthly. So that will be 3 multiplied by 12, of which the entire thing here, which I made a mistake. Sorry guys. So it's 1 plus 10. I'm getting a very ridiculous number. 10% into 8.5 divided by 12, that is 29 multiplied by 12, minus 20,000 into 1 plus 8.5% and 3 multiplied by 12. Okay, I'm getting a very not so nice number. Okay. Okay, I see where I made a mistake here. Reason why, now that we have a minus here, I should only have added this and this side here. Alright guys, I made a mistake, and I see where I made a mistake. I hope you guys have figured it out as well, that I made a mistake somewhere. The mistake is I should have done this on the side and also this on the side, so that this will add the 25,000 and then divide it with this 2 on the 25,000 there. So in this case it will be 25,000 and then plus 20,000 into 1 plus 8.5% divided by 12 multiply 3 multiplied by 12, and all this will be divided by 1 plus 10% divided by 4 into 4 multiplied by 4 into also again 1 plus 8.5. So guys, it's actually 8.5 here. It's 8.5% divided by 12 into 9 multiplied by 12, and this right here will give us the right answer. Alright, sorry for the mistake that I made. So it's 25,000 plus 20 into 1 plus 8.5%, forgot the percent, divided by 12 to the exponent of 3 multiplied by 12, which is 36. So here we'll have in the denominator 10% again, divided by 4, it's compounded quarterly, and to the exponent of 16 into 1 plus 8.5% divided by 12 to the exponent of 9 multiplied by 12. And here we'll have our amount, which is the original amount which was invested is 15,962.41 cents. Alright, it's just that it can be seen clearly, but it's that's the amount that was originally invested, 15,962.41 cents. Alright guys, I hope you guys understood the calculation here, that okay, we had the final amount in this case that you will withdraw, which makes it A, is 25,000. Alright, and then here we'll have our P, which is what we're looking for, is the original investment. And our interest rate for the first 4 years, we were told that it was 10% compounded quarterly. So here it will be 10% divided by 4, and it only was there in the account, it was only applied for 4 years. That's why it has to be 4 years multiplied by 4, and therefore it's 4. That means it was compounded quarterly. And continuing, because the interest rate changes for also the original amount, then we multiply again with 1 plus 8.5, because the interest rate changed after 4 years to be 8.5 compounded monthly this time, and it was only in the account for 9 years. Remember that this account will only be for 13 years, because it was made at 8 years, and also it was the end of it was in year 21, of which the period between 21 and 8 years is 13 years. That's why the first it was 4 years, and the remaining period will be 9 years. And then we subtract the withdrawal together with its interest. Remember, withdrawal happened on her 18th birthday, so that means that it was 3 years before the end of the account. So it was only we subtract the withdrawal together with its interest for 3 years. Alright, and after that, that's what we have. And what we do now, because remember, this is a matter of like terms, if you can remember from algebra. I cannot be able to add those two or subtract those two, reason being we have a P which is unknown there. So what we do is 25,000 here, which is on the other side of the equal sign. I can actually add it with this part of the equation here, which is the withdrawal. And after I did that, then I can divide with this, so that I will have my P as the subject with the formula. And at the end, after doing the calculation, we found that the original amount which was invested, it was 15,962.41 cents. Alright, I hope you guys understood this question. And then the question one, the second question, it says, hence, if Linda doesn't withdraw 25,000 on her 21st birthday, how much will she have on the 30th birthday? So in this case here, what we do is 25,000 now becomes the principal amount, that this is what we will now be investing, and at an interest of 8.5 compounded monthly, and this time it will be only for 9 years, because we are calculating from her 21st birthday up to her 30th birthday. Alright, so I'll just flip the board. Guys. Okay, I hope you guys still remember the question, that now we have A is equals to P into 1 plus I to the exponent of N. And in this case, what we're investing is the 25,000 that she didn't withdraw on her 21st birthday. So the interest rate is still the same for the period of 9 years, of which it was 8.5%, and this one is compounded monthly. That's why we have to divide by 12, and to the exponent of 9 years, because from her 21st birthday to her 30th birthday, it's a period of 9 years, and the 9 years we also have to multiply this with 12. So we just have to punch this. This was an easy one. The only trick thing is just that we have to understand that the 25,000 now becomes the investment, the principal amount that she will be investing on her 21st birthday, so that she will withdraw it on her 30th birthday. So that will be 1 plus 8.5%. Remember, it's compounded monthly, that's why we have to divide by 12 to an exponent of 9 multiplied by 12, of which on her 30th birthday she will be having 53,580.18 cents. So it's actually much better to withdraw on your 30th birthday, because the amount will be a double, and double plus the original amount which you would have invested 9 years before. Alright guys, I hope you understood everything in this lesson, and if you didn't, you know the drill. You just leave us a comment and then we'll contact you to explain further on this content. And also don't forget to subscribe to Maths XYZ channel on YouTube, so that every time when we upload videos you will be able to receive a notification. Thank you.